Hopefully that video explained a little bit more about telomeres and how they work and how telomere erosion can be prevented by the enzyme telomerase. Now, we spoke earlier about how DNA is packaged in the nucleus uh, with proteins. So I want to say a couple things about the proteins and about the arrangement of DNA, how it's wound around these spools with these proteins that are called histones. Histones are proteins that form complexes that are usually in octamers or 8 parts that the DNA can wrap around to function like a spool. And DNA can wrap twice around one of these octamers and form what's called a nucleosome, or a bead on a string. And then these can help keep the DNA from becoming a tangled mess, like your headphones in your pocket. If you have your iPod headphones or your iPhone headphones, stick them in your pocket, and they'll become a tangled mess in no time at all. So the DNA double helix, recall, is 2 nanometers wide. The nucleosomes are 10 nanometers in diameter, and then they can form what's called a 30 nanometer fiber. That's what you can see here. And these 30 nanometer fibers can then be looped around to form a 300 nanometer fiber into these looped domains. And then our chromatids, when we're all condensed, are about 700 nanometers wide in a metaphase chromosome. So when it is in interphase, the chromatid is usually found as a 10 nanometer fiber, but it can be compacted in that 30 nanometer fiber as it's folded and looped. At interphase, the chromosomes are not highly condensed, although we know from looking at that photomicrograph I showed you previously that there are definite regions, specific regions within the nucleus where the chromatin that forms that chromosome may reside. So this looks like maybe it's part of chromosome 5, and over here is maybe a little bit of chromosome 4, or who knows. So most of the chromatin is loosely packed in the nucleus before mitosis, and we call that loosely packed chromatin euchromatin. But some regions of the chromosomes, the centromeres and the telomeres, remain highly condensed. We call that heterochromatin. And heterochromatin, because it is so densely packed, if there are genes that are present in those regions, it makes it difficult for them to be expressed. That DNA, if it's all wound up, it's hard to get at the thread that's in the middle of the spool. But if it's on the outside of the spool, it's easier to get to. And that's sort of what's happening in heterochromatin. So that's it for chapter 16. Up next is chapter 17.